Hey, welcome to Models and Agents, Episode 9 for March 8th, 2026, your daily briefing on the AI models and agents that are changing everything. And no, not those kinds of models and agents. Let's get into it. Meta's new research trains multimodal AI on unlabeled video, challenging assumptions about text-heavy scaling. All right, that right there is the kind of development that gets me buzzing, because if you've been following the scramble for quality training data, this could be a game changer. Stick around as we dive into how video might just unlock the next wave of multimodal AI, plus some eye-opening insights on agent benchmarks and a fresh tutorial for building smarter agents. Whether you're fine-tuning models or just trying to make sense of it all, we've got the practical angles covered. So what you need to know today, Meta, FAIR and NYU researchers have demonstrated that unlabeled video could be the next big frontier for training multimodal models, potentially bypassing the drying up of high-quality text data by leveraging vast video datasets for better generalization. Meanwhile, a study highlights how AI agent benchmarks are overly focused on coding tasks, missing opportunities in broader labor markets, and a new tutorial offers a hands-on framework for building advanced cognitive agents with memory and validation. This week, pay attention to how video data might shift multimodal training paradigms and explore agent frameworks that emphasize planning and real-world applicability beyond just programming. Let's jump into the top story because this one has me genuinely excited. It's one of those moments where research flips a long-held assumption on its head. Meta's FAIR team, working with researchers from New York University, just released findings on training a multimodal AI model entirely from scratch using unlabeled video data. Now, if you're not deep in the weeds, multimodal models are those that handle multiple types of data, like images, text, and now video, to understand the world more like we do. The big assumption they've challenged is that you need tons of carefully labeled text data to make these models work well. Think how models like GPT-4v or Gemini rely heavily on paired text-image datasets for supervision. What they did instead was build a vision language model that learns from raw, unlabeled videos, tapping into the temporal dynamics, basically how things change over time in video, to infer patterns and relationships. The results? This model showed strong performance on tasks like image classification and visual question answering, actually outperforming text-only baselines when it comes to generalization. That means it handles new, unseen scenarios better, all while using less curated data. Compared to something like GPT-4v, which leans on massive text corpora that are getting harder to source ethically and abundantly, this approach points to a more efficient path forward. Or take Gemini, it's powerful but still text-heavy in its training. This video method could scale multimodal capabilities without depleting those text resources. Why does this matter for you? If you're a developer building vision AI, say for apps that analyze real-world footage or augmented reality, this suggests experimenting with unlabeled video could make your models more robust without the hassle of annotating every frame. It's a genuine step forward in tackling data scarcity, though fair warning, processing video still demands serious compute power, so you'll need access to GPUs or cloud resources. Meta hasn't dropped a public model yet, but they're hinting at integrating this into future Llama variants which are open source friendly. In the meantime, try weaving video datasets into your fine-tuning pipelines for multimodal retrieval augmented generation systems. Pair it with something like a vector database, and you might see better handling of dynamic content. This isn't hype, it's a practical nudge toward more accessible training methods, and I'm stoked to see where it leads. Shifting gears to model updates, there's a fascinating study out from the Decoder that really calls out a blind spot in how we're evaluating AI agents. They dug into popular benchmarks and found they're obsessed with coding tasks, stuff like writing Python scripts or debugging code, which only covers about 8% of the US labor market. Meanwhile, huge sectors like healthcare, education, and retail, which make up the other 92%, get almost no attention. Think about benchmarks in tools like LangGraph or AutoGPT. They're great for code generation, but that focus leads to overhyped claims about how ready these agents are for the real world. For example, LangGraph excels at structuring agent workflows around coding evals, often pulling from GitHub-style tasks, but it doesn't simulate something like managing patient records in healthcare or optimizing inventory in retail. AutoGPT is similar. It's agentic and autonomous, but its benchmarks skew toward programming, missing out on testing diverse skills like decision-making in non-technical environments. This skew isn't just academic. It limits progress in building versatile agents that could automate everyday jobs. If you're a practitioner, this is a wake-up call to adapt or create benchmarks for those non-coding domains. Maybe expand beyond GitHub-centric evals to simulate real workflows. Test your agent on something like a virtual retail scenario where it has to handle customer queries, stock checks, and sales predictions. It fits into a bigger trend of pushing agentic AI toward broader applicability, and honestly, it's about time we balance the scales. I've seen too many demos that wow on code but flop on practical tasks, so this study is a solid reminder to think bigger. Now, for agent and tool developments, I want to spotlight this new tutorial from MarkTech Post. It's a complete framework for building next-gen agentic AI, and it's got me itching to tinker. They lay out a cognitive, blueprint-driven approach for runtime agents, which basically means structuring your agent with clear elements like identity, goals, planning, memory access, tool calling, and output validation. This lets the agent plan, execute, and even self-improve in a systematic way, making it more reliable for multi-step tasks. Compared to basic setups in frameworks like Crew AI or Microsoft AutoGen, this adds memory tools and validation loops which cut down on hallucinations, those pesky made-up responses, and boost overall alignment. Crew AI is solid for team-based agents, but it can lack built-in validation. AutoGen handles multi-agent chats well, but this blueprint integrates memory more seamlessly for long-term reasoning. The cool part? It's open source friendly. You can follow the step-by-step guide to build your own, starting with a simple JSON blueprint and hooking it up to models like Llama 3, which is free to use via Hugging Face. If you're into agents for planning heavy workflows like automating research or content creation, this is particularly novel because it emphasizes self-improvement loops. No massive barriers to entry, just grab an open LLM and get started today. I love how it reduces the chaos of agent runs. Definitely give it a spin if you've been frustrated with unreliable outputs in your setups. All right, let's talk practical and community stuff because this is where the rubber meets the road for a lot of you building day to day. That MarkTech Post tutorial I just mentioned is a standout. It's essentially a community-driven gem, offering a hands-on way to level up your agents with memory and validation, which solves common pain points like inconsistent results in multi-turn interactions. It's built on open-source principles, so anyone can fork it and adapt. Pair that with the insights from the Decoder study, which is sparking community discussions on GitHub and forums about expanding benchmarks. I've seen devs sharing custom evals for non-coding tasks like simulating education workflows or healthcare triage, underrated projects that could help you identify gaps in your own agents. If you're dealing with real-world applicability, these community contributions are gold. They highlight how we can move beyond coding hype to agents that tackle broader labor markets. Another angle, the meta research is inspiring open-source experiments with video data. Folks on Hugging Face are already sharing notebooks for incorporating unlabeled videos into clip variants, which is a low-barrier way to try multimodal tweaks. This stuff addresses the overwhelm of rapid changes by giving you actionable, community-backed tools. Definitely check out those shared repos if you're into vision tasks, as they often include starter code to get you experimenting without starting from scratch. For things to try this week, I've got a few specifics pulled from today's developments that could really amp up your workflow. First, try incorporating unlabeled video datasets into your multimodal training pipelines with models like Llama or Clip variants. It's worth exploring for better generalization in vision tasks without heavy text annotation, especially if you're working on image or video analysis. Second, check out the Cognitive Blueprint framework from the MarkTech Post tutorial if you're building agents for planning heavy workflows, as it adds memory and validation to make outputs more reliable than standard LangChain setups. Define your blueprint in JSON and integrate with Llama 3 for quick wins. Third, compare agent benchmarks beyond coding by adapting open evals from the study. Test your agents on non-programming tasks like simulated retail scenarios to identify gaps in real-world applicability, which could reveal where your agents need more balance. And finally, experiment with video-based pre-training for RAG systems. Pair it with vector databases like Pinecone to see if it boosts performance in dynamic content retrieval over text-only embeddings. These are all doable today, and they tie right into the shifts we're seeing. Looking ahead on the horizon, keep an eye on Meta's potential integration of video training into future Llama releases, which could lead to more efficient multimodal models. We might see expanded agent benchmarks targeting non-coding labor sectors, influencing updates to frameworks like LangGraph or AutoGen. There are community-driven extensions of the Cognitive Blueprint framework coming, including integrations with tools like Semantic Kernel for edge deployment. Plus, regulatory discussions on data sourcing for AI training are heating up. especially around video datasets and their privacy and alignment concerns. Just when you thought you'd caught up, right? Before we go, tomorrow, keep an eye on emerging details about Meta's Llama updates that might incorporate this video research, potentially dropping some accessible tools for multimodal fine-tuning. That's Models and Agents for March 8th, 2026. If you found this useful, share it with someone who's trying to keep up with all these changes and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow.